Let's begin this lesson by considering a question. Julian and Derek play on the same baseball team. Julian has 6 hits after 9 times at bat. Derek has 17 hits after 27 times at bat. Which player has the better batting record? One option is to say that Derek has 17 hits and Julian only has 6. Therefore, Derek must be the better batter. But this doesn't really seem fair, because Derek has had more opportunities at bat to get a hit. So perhaps a better option is to compare the ratios of hits to total at bats. But how do we compare the ratio 6-9 to the ratio 17-27? What would happen if both players had the same number of at-bats? Who would you expect to have more hits? Let's consider the following 2 diagrams. Notice in the first diagram that there are 4 circles and 3 triangles. The ratio of circles to triangles is 4-3, and it means that for every 4 circles, there are 3 triangles. In the second diagram, there are 8 circles and 6 triangles. The ratio 8-6 means that for every 8 circles, there are 6 triangles. Can you use these 2 diagrams to convince yourself that 4-3 and 8-6 represent the same ratio? There is no doubt that the second diagram contains more circles, but it also contains more triangles. If you ignore how many of each shape there are, you might notice that both diagrams express the same relationship, that for every 4 circles, there are 3 triangles. This is much clearer if we organize the shapes in each diagram a bit better. Notice now that in the second diagram, the statement for every 4 circles there are 3 triangles still holds true. And so both diagrams represent the same relationship between the quantity of circles and triangles. We call the ratios 4-3 and 8-6 equivalent ratios. By definition, 2 or more ratios are equivalent if they represent the same relationship between numbers. Example: using a diagram, show that 2-5 and 6-15 are equivalent ratios. First, let's represent the ratio 2-5 using a diagram. In my diagram, I've represented this ratio by drawing 2 stars and 5 diamonds. It's possible that your diagram might look different. Remember, though, that the ratio 2-5 means that for every 2 stars, there are 5 diamonds. So we can create other diagrams that maintain this relationship, but contain a larger quantity of stars and diamonds. For example, if we have 2 copies of the diagram, then there are a total of 4 stars and 10 diamonds. The ratio of stars to diamonds is 4-10, but also 2-5. If we include 3 copies of the original diagram, then there are a total of 6 stars and 15 diamonds. The ratio of stars to diamonds is 6-15, but also 2-5. These 3 diagrams all express the same relationship, that for every 2 stars, there are 5 diamonds, thus showing that 2-5, 4-10, and 6-15 are all equivalent ratios. So not only have we shown that 2-5 and 6-15 are equivalent ratios like the question asked us to do, we have also shown that both are equivalent to the ratio 4-10. As an exercise, see what other equivalent ratios you can find.